already talked about the first and second layer of the sun. Now it's time to talk about the third layer of the sun, well, from the core. The third layer is called the convective zone. The name basically describes it. Heat goes through this zone in form of convection. Do you know how convection works? Let's say you're boiling a pot of water. The hotter area of the water has a lot more energy than the colder areas. So, naturally, the hot water will want to rise to the top. The cold water on the top wants to go down to the bottom. That's why convection works. Because hot water wants to go up, cold water wants to go down. Let's take a single little particle from the bottom of the pan. Because the bottom of the pan heats up first, the column of hot water will rise up to the surface. Once this column of hot water is at the surface, it will lose a bit of heat in form of radiation or conduction, and it will go back down because now it's colder. And now, since it's back down to the bottom, it will pick up even more heat and then go back up, lose a bit of heat, go down, gain heat, go up, and then the cycle continues. And that is convection. If we put that into the sun, you can see that this works really well as a form of energy transfer. The heat goes from the core to the radiative zone, and then at the end of the radiative zone, it gets picked up by the convection currents like a taxi, or as I like to call it, a spinner wheel. If you find any photos of the sun or any slideshows of a certain point of the sun, you can see that these convection currents are always changing. It makes it look like this slideshow is from this angle, then this angle, then this angle, and then this angle. But actually, it's from the same angle. The convection currents are just actually moving around. Some of getting smaller, some of them are getting bigger, some disappearing, some appearing. It's always changing. It's like when you boil water. There's bubbles getting bigger, smaller, appearing, and disappearing. Some of you might think that the sun is a perfect, smooth ball of hot gas that is on fire. Well, the sun isn't actually on fire. It's just a bunch of plasma squeezed into a teeny weeny little spot. This plasma isn't even everywhere on the sun. So, it's not perfect. That's why these convection currents are constantly changing. If somehow people find out how to stabilize the plasma on the sun and stop it from doing what it does, then these convection currents will look like dots on the sun, not moving at all. Since this zone carries a lot of heat using convection, it gets super duper hot. It is around 2 million degrees Celsius on average. Have you ever ridden a roller coaster before? Some of you might have already ridden a roller coaster and saw that when you turn like this, boom, like that, you can see that your body wants to fly this way or this way. This is centripetal force pushing you in a certain direction. If you want to move, you're going to have to apply a force on your body. That's your muscles. In physics, objects that are stationary don't want to move. objects that are moving don't want to stop moving. It's exactly like my brother.
What?
Because this centrifugal force, the sun is continuously spinning around and around. And because it's spinning around and around, it's elongated on the side a little bit, just teensy bit. So, since this layer is very vibrantly yellow, if you look at it from the side, it kind of looks like a big spherical or oval lemon. It's
Lemon.
Yes, lemon.